Hello guys and girls. Today we're going to talk about factoring. Factoring is the process of finding the factors of a polynomial. So what is a factor? Well, let's think about a whole number. If I talked about the number 12, I'm talking about the two numbers I can multiply to get 12. I can multiply 1 and 12, so they're factors. I can say 2 and 6. I can say 3 and 4. So they're all factors of 12. Okay, factoring is like reverse multiplication. Okay, that's right in the word multiplication. We are finding out what polynomials were multiplied together to get the polynomial we are factoring. And finding a greatest common factor is the first step. So the greatest common factor, or we call it the GCF. Okay, so the GCF can be numbers and or variables. So when we're working with polynomials. So if I had for example, say I had the number 6x squared y. I had the monomial 6x squared y, and then I had the monomial 8xy squared. And I wanted to find the greatest common factor. I would first look at the coefficient, and the numbers 6 and 8. Well, 6 and 8, let's see, my factors of 6 are 1, 2, 3, and 6, and my factors of 8 would be, well, 1 and 8, 2 and 4, so it would be 1, 2, 4, and 8. So my greatest common factor for the coefficient would be 2. All right, so 2 would be the coefficient, and now x, I've got x squared and I've got x, okay, so the one that we have in common would always be actually to the lowest exponent, so it would just be x. Okay, because x is a factor of x squared and x is a factor of x. And then with our y's in this case, we've got y and y squared, so it would work the same way. We've got y and y squared, so the only one we have in common would be a y. Okay, so the example we have says, find the greatest common monomial factor, the GCF, of 30 n to the third and 42 n to the second. I'd look first at my coefficient and list my factors of 30 and then list my factors of 42. My greatest common factor would be 6. Okay, and then looking at n to the third and n squared, my greatest common factor would have to be n squared. So looking at 30n cubed and 42n squared, the greatest common factor would be 6n squared. Okay, so looking at the examples that we have here, let me just move this over a little bit. Okay, let's see if I can move this. Hold on. There we go. Okay. All right. So we want to factor out the greatest common monomial factor. So if I look at 12 and 42, and you might have to go through a lot of numbers. Maybe you list them out like this, 12 and 42, and you say, well, 1 and 12, 2 and 6, 3 and 4, those are all my factors. And then maybe you say 42. 42, you could multiply 1 and 42. It's even, so I might say 2 and 21. It's divisible by 3, so 3 and 14. 4 doesn't work. 5, 6, and 7. Okay, so now looking at that, 6 is actually the greatest common factor. So, and then I don't have anything for the variables. I don't have a variable in common. So my greatest common factor would actually be 6. So I can pull out a 6 and say, well, 6 times what is 12x? It would be 6 times 2x, and 6 times 7y would be 42y. So kind of did a reverse distributive there. So we pulled out the 6, or we factored out the 6. Okay, in this example, 4 and 24 for number 2, 4 is actually the greatest common factor. So for both, so I'm going to pull out a 4, and then my x, I've got x to the fourth and x to the third. Well, anytime you have the same variable, it's always going to be the lowest exponent that you can factor out. So in that case, I pull out a 4x to the third. That means for the first term, I multiply by x, and then the second term, 4 times 6 is 24, and x to the third times 1, so it's just 4x to the third times x plus 6. Okay, number 3, I'm going to factor out a 3, but I don't have any variables in common, so I'm just left with 2x squared minus 5y. Okay, Number 4, I'm going to factor out a 3 because I've got 9 and 3, and I'm going to get an m squared because that's the lowest exponent. When I reverse it, 9 divided by 3 is 3. M to the 7th divided by m to the 5th is, second is m to the 5th. And then 3m squared divided by 3m squared is just going to be a 1. So I factored that out. Okay, 5 and 2, if the coefficients don't have, if there's no greatest common factor, in this case it's 1, you just leave it as just the variable. Here we have d to the 5th and d to the 2nd, so we're going to factor out a d to the 2nd. And then we're left with 5d to the 3rd plus 2. Okay, so why don't you pause the video and try a few of these on your own, and then I'll continue on from here. Okay, so number 6 would be 5. It would be the greatest common factor. We're going to, oops, I forgot about my variables. Okay, so if I look at n to the 3rd, it's not erasing for me. Come on. Okay, come on. Not sure why it's not doing it. Okay, there it goes. Okay, so we've got n to the 3rd and n, so it would be 5n that we would factor out. We're left with 3n squared plus 5. Okay, so I'm going to go through these right now. I'll give you the answers, or you can look at the key on student view, and you can try them on your own. But I'm going to write them in here right now. Works the same with 3 terms. Okay, this would be 9p times p to the 4th minus 3p minus 4. 10 would be 2c times 2c cubed plus 3c plus 6. 11 would be 9ab times 3b to the 4th minus 5ab squared plus 2a squared. And 12 would be 13 sw squared times 1 plus 3 s squared w. Okay, so here we factored out the greatest common factor. Okay, the next part that we're going to do is actually kind of a little puzzle. So we're looking at, it's called the sum and products puzzles. In the diagram below, write the 2 numbers on the sides of the x that are multiplied together to get the top number, but add together to get the bottom number. So you've got to look at the factors. So if I looked at negative 48, okay, I know that I can multiply 1 and 48 and 2 and 24. Okay, I can multiply 3 and 16, 4 and 12, and 6 and 8. Okay, and I'm going to play around with the negatives to get to the negatives. So I want to multiply the 2 numbers together to get negative 48, but then add up to negative 13. So a lot of times I just look at the differences to be 13. And 1 and 48, the difference is 47. That's going to work. So right here we've got 3 and 16. So 3 and 16, now one of them has to be negative in order to get the negative 48, because we're multiplying up here, but we're adding down here. Well, in order for this to be a negative 13, the one that's negative is going to have to be the 16. So we'd get 3 and negative 16. So for negative 36, that's actually a little bit easier. In order to multiply and get negative 36, we're going to take 6 times a negative 6, and if they add up to 0. Okay, for negative 70, if we had a 14 and a negative 5. So 14 times negative 5 is negative 70, but they add up to 9. So I want you guys to try the puzzle and then check the answers. So this is going to be a 2 and a negative 22. This is going to be a negative 7 and a 6. Here we'd have a negative 8 and 9. I'm going really fast because I'm assuming that you've already tried these and you're just checking. Number 7. Well, 1 times 24 is 24, okay, and they add up to 25. For 11, I can take 7 times 4 to get 28, and 7 plus 4 is 11. Okay, number 9, I'd have 2 and 17. And then number 10, you could have negative 4 and negative 4, because see here you multiply 2 negatives, you get a positive, and it adds up to negative 8. And then number 11 is negative 18 and 2. And number 12 is 5 and 5. Okay. All right. I'm going to pause the video right here because the next part of the notes is going to be talking about factoring trinomials. We're going to use what we learned here, but I want to have a little bit more time. So pause the video video and then you can watch the next one.